Lesson 2.3, Solving Systems of Equations Graphically. It's MA 912, AR 9.3. So again, a system of equations is a set of two or more of the same variables. We have one method which is called graphing, and our point of intersection of the two groups is going to represent the solution. So there's some types of graphs that we have. Our first one is where we have one point of intersection. That means they have different line slopes. There's going to be one solution, and it's known as consistent and independent because each one has its own graph. The second type we have is one where the lines are identical. What that means is they have the same slope and y-intercept. The number of solutions it has, it means it has infinitely many solutions. It means I can pick any point along the line. Well, these type of graphs are known as consistent, but they're dependent one on the other. The third type of graph we have, the lines are running parallel to each other. What that means is they have the same slope, but different y-intercepts. There's going to be no solution because they will never cross each other. And these type of graphs are known as an inconsistent system. Example 2, solve a system of equations by graphing. So they gave us the equations 5x minus y equal 3 and negative x plus y equal 5. So to solve each equation for y, so it makes it y equals mx plus b format. So you want to change it into y equals mx plus b. And then says solve each equation for y, graph the different slopes, so then you have your solution. So the first one, when we solve it for y equals mx plus b, if I were to swap my y and 3, I become y equals 5x minus 3. If I add x over, I become y equals x plus 5. So the line appears to intersect at, that's 2, 1, 2, 3, 4, 5, 6, 7, at 2, 7. So in order to check the solutions, you just plug in your values. So we did 5x minus y equal to 3. We plugged in 2 for x and 7 for y. So 5 times 2 is 10. 10 minus 7 is 3. 3 equaled 3. And then we plugged in 2 into the next one and 7 as well. So it's negative of 2 plus 7. Well, negative 2 plus 7 is 5. 5 equals 5. So our solution is 2/7. In our check problem, it says solve the system equations by graphing. So when we look at our check problem, the first equation is 2y plus 14x equals 6, negative 6. First thing I notice before I start anything is that all of them are even numbers. So I can actually just divide first everything by 2. So become y plus 7x equals negative 3. And then now I can just subtract my 7x over. And I get y equals negative 7x plus minus 3 actually for your first equation. Then we have our second equation, and our second equation says it is 8x minus 4y equaling negative 24. And again, I notice that instead of 2, they're all factors of the number 4. So I can divide everything by 4. And I become 2x minus y equaling negative 6. And we'll just do a simple swap of positions here. So we're going to have y equals 2x, and then the 6 becomes a positive 6 now. Positive 6 at that point because it was negative and swapped over. So we have our two equations, and we're going to graph our points. Now notice that our graph does not have enough point values for the numbers we have, starting values for slope. You could do increments of 2 if you wanted to, but for this purpose, we have starting at positive 6. 1, 2, 3, 4, 5. So I'm going to go increments of 2, 2, 4, 6 to put my first dot. And then I'm going to go up 2 over 1. So I'm going to be a halfway point, and I draw my first graph line. The second graph, our first one that we had, says it started at negative 3. So it's starting at negative 3, so it's the halfway point, and it's going down 7. So that's 2, 1, 2, 3, 4, 5, 6. It's going down 7 over 1, and it's coming at that point. So when we look for a point of intersection, it is intersecting at negative 1, 4, negative 1, 4. In example 3, it says solve the system of equations. We have 7x plus 2y equals 16 and negative 21x minus 6y equaling 24. So we're going to start again with our first equation, which is 7x plus 2y equaling 16. We look at, see if they have a common number. They don't. So we are going to subtract 7x to the right. It will become 2y equals negative 7x plus 16. And then divide everything by 2 to reduce, and get y equals negative 7 halves x plus 8. Negative 7 halves plus 8. Then we go to our second equation, and our second equation says it is negative 21 x minus 6y equaling 24. When I look at 21, 6, and 24, they are all factors of the number 3. So we're going to divide each of them by 3 first. And we become negative 7x minus 2y equaling 8. We are going to then add 7x over. And we get negative 2y equaling 7x plus 8. And then we need to divide everything by negative 2. And we get y equals negative 7 halves x minus 4. Negative 7 halves minus 4. Okay, so now the thing is that we notice is the equations have the same slope but different y-intercepts. So these equations represent parallel lines, and there is no solution. So we could graph each one, and we can notice that they do not intersect one with the other. In example 4, it says write and solve a system of equations by graphing. So it says suppose an electric car costs $29,000 to purchase, and it costs 0.36 cents per mile, so basically 3 cents a mile to drive. Then your gas-powered one is $19,000 to purchase, and you're paying 8 cents per mile to drive. It says estimate after how many miles is each one equivalent. So first thing we're going to write is your equations, and it says let y equal the total cost of owning the car and y the number of miles driven. So the equation for the first one is it's 0.036x plus 29,000, because that is your electric, and then 0.08 and 19,000 for the gas-powered one. In part B, they want us to estimate the cost, and they did draw our graphs for us. So we're interpreting what they have. So notice that the x-axis says miles and thousands, and your cost is in thousands of dollars. So when they intersect, they're intersecting at this point right here. So you're going to approximate an answer. So using Desmos graphing calculator, you can plug in both equations, and it's going to give you an exact spot. And it says it's at $225,000, or miles actually, 225,000 miles. And 37,500 miles between them. Because remember, we're comparing the gas to the electric. Now, this means that after driving about 225,000 miles, the cost of both cars are the same. In order to check it, you would basically take your equations and plug in those values for x and y. So When we did 0.036 with X, where we plugged in the 225,000, added the 29,000, and seen if it cost 37,500, we noticed that they're similar. Remember, this is not approximation. These are within reason. So it's about 400 miles off. So it's equivalent and it's a reasonable answer. When we did the 8 cents, set 37,000 to the 37,500. So again, the estimated number, it said estimated. We didn't say it's going to be exact. Estimated number of miles for both equations is an approximately true statement. So it means that they are reasonable in their pieces.